So hello, welcome everybody to the talk about Mobile ID, the framework for secure transactions. I hope you all enjoyed lunch and are now ready for security again. My name is Peter Waldegger. I started out 20 years ago as a software developer and was developing software for smart cards, starting with the real profile on the smart card, the card driver, PKCS11, the plugins on Windows, CSP, or on Unix, the pluggable authentication modules. And we did quite a lot of cool stuff in all platforms. But of course, that was very intensive work and also very expensive. Fortunately, we had a lot of banks and insurance companies that wanted to have high security, so they paid for it. But as soon as these companies had their solution, there was no more other interested to go on, and it was integrated in Windows. Every platform now has the support for smart cards, and so my question was, where is it going now? And that's the reason why I come to Swisscom, or why I went to Swisscom. The interesting thing is now the connectivity. So all objects are connected. We are in moving to a world where everywhere is a connection between the objects, and security is moving out on each device. And of course, with Swisscom, there is another opportunity to do cool stuff. And who of you knew that Swisscom was in the field of security? Okay, so that's a pleasure to see it. Swisscom was in security since the early days. If you look at this picture, what does it mean? So it is something about identity. Each phone had its own dedicated line that went from one desk to the other, and was this copper line. And it has also to do with the security. So the data centers had to be shut up, and no one could tap the line. And you knew that if you had a connection with somebody, then it was on the right desk, on the right building, on the right place. Since that days, a lot has changed, so that's not an actual picture. Today we have convergence of the technologies. So the data, the movies, the pictures, the management information, the private data, the corporate data, everything goes over just one line, and it's very difficult to differentiate what is from where and who is on the other side. That's the challenge where we are going today. And that's also the reason why Swisscom is investing a lot in security, in identity, in knowing who's on the other side. And one of these solutions is the Mobile ID. If you look back at the picture before, where we had these plain old telephone lines, the solution was not only in the line, but also in the protocol you had. If somebody called you and told you, "Hi, I'm Joe, I'm from the controlling department, please give me the latest figure." And you thought, maybe it's Joe, maybe not. Should I give him the figures? I said, okay, cool, I collect them and call you back. So you choose the telephone book, looked up the number of Joe from controlling. If you find him, you knew that it was the right guy and called him back. So there's more security in how you handle the technology than in the technology itself. Just let me show you one picture to make this point again. So if you see this water, would you drink it? Yes or no? But maybe it depends. It depends on what you know, where you are, what you expect, what your information is. Maybe you heard on the radio that there is a small problem with the water, but in fact it's clean or not, no problem to drink. So what you really do and depends on what you know. And that's where the security is going. If you look at the picture how internet or e-banking security is done today, we already heard this morning, the problem is that if you send something from your laptop or from your e-banking account, on the other side, on the bank, they don't really know if what they received is what you sent, or if there is some man in the middle or man in the browser that changed your information. So they use some new technologies, sending SMS to you, asking you, hey, that's what we received. Is this really what you send? And they use you again to make up some protocol where there's more security in the technology. And who's providing the base technology? Well, for the connectivity here is Swisscom, and on the other side here is also Swisscom. And we analyzed the situation and asked us how could we put more security in this whole transaction here, because the underlying concept had not been built for the security. It has been built for communication, sending short messages. But it has no authentication, and we don't know how the confidentiality is handled. And of course, it has no way to have non-repudiation. So it cannot prove if what he says here or what we uses the phone for was really what he wanted to receive. And that's what we asked us, how could we achieve more security in all this stuff? And with the mobile technology, we ended up in something that we called Mobile ID, that supports a lot of use cases where we think the future will go, and we'll need them to provide secure transactions or applications. But what we build is just the base. So it's just the communication and the framework how applications can be made secure. And what has to be done over this layer are the application itself. We don't provide the application. That's why we call it just a framework for secure authentication and secure transactions. I will give you the examples what transactions can be done in a few moments. I just want to show you what I understand when we talk about mobile ID, because mobile ID is a buzzword, and there are a lot of solutions that use the word mobile ID, which are good in what they are doing, but it's not one concept that everybody has the same view on it. What I want to point out, or what we are seeing as the base functionality that's needed within a mobile ID, is of course it's available on cell phones, because everybody has his cell phone with him, so it's something that's ubiquitous. It's based on, we use the SIM card to store the encryption and to do the encryption. So we have the computing power and the secure storage for the cryptographic information on the user. Everybody has it in his pocket. And of course we use the SIM card or eSIM card or whatever they are for technology to execute the cryptographic operations in it. Yes? Mm-hmm. So the question is about the performance and how it's the usability. I come, yes. So come back to your question. I give you an overview of how the security concepts are built, and then we can come back to the question. But just to make it short, we have a prototype that's running And I can show it to you on our booth if you want to come there to see how the performance is and what's going on there. But there is, it's a good question. I hope that some answers you'll find in the presentation in further steps. What's also within the concept, what we understand as a mobile ID is that the messages that are sent to the phone can be encrypted and are encrypted for that phone only. So you have the confidentiality on the line, and what you receive and what you confirm on the phone can be sent back signed, and you have the non-representationality. You can have non-represent. You can prove that it's what the user said. That's only the technology. That's the base. What's underlying under the mobile ID. But the important part is that the supporting processes need also to be made in a way that's secure. What do you understand regarding the process? For example, the SIM card that's within your mobile phone, it has to be provided to you in a secure way, in a trusted path, so that it cannot be exchanged with an unsecure SIM card over the way until you have it put in your phone. The initialization itself has to be done in the manufacturer or in a secure environment where you know that it's really written on the card what you expect to be there and nothing else. The user identification, how the phone is handed over to the user or how the key is bound to the user with where he enters his PIN for the key, has to be done in a secure way, because if the wrong user receives the SIM phone, he can impersonate somebody else. And this also leads that the activation personalization processes all have to be done in a secure way. So there is a lot more than technology in it. There is a lot of processes that have to be set up and be executed in a trusted way. So I think the best thing would be if I give you some examples how this mobile ID can be used. So the first use case is access to the LAN. It's simple to imagine. Just think of what you use today, for example, secure ID, if you want to access the LAN from your home on your corporate network. So an employee who is outside the corporate network wants to access his LAN, and where he usually uses, he starts a VPN, and where he usually uses his secure ID to enter his credentials, he can just use the smartphone. The advantage of the smartphone is he always has it with him. If I forget the phone at home, I will go back and fetch it again. If I forget my secure ID at home, I will just see it when I need it, when it's too late. So that's it's a big advantage of the phone. And the smartphone is also always connected. It is always loaded. The user looks himself for his smartphone. So can you see the bottom of the pictures? Okay, I go through the process. I have here 3 layers. One is the employee, so it's in this example it's his home. The second is the corporate network, that's where he wants to connect, and the third one is the mobile ID backend. That's the service layer of the provider. So what he does when he wants to log in the network is he just starts his VPN, which builds a connection to the VPN connector. That's the same as if you do the login with secure ID. The VPN connector will check the user credentials or whatever is provided for information about the user. He maps the username to his mobile number and then requests the authentication in the provider network. The provider will send an SMS, which is an encrypted binary SMS, to the cell phone. The user confirms the access. He has to enter a separate PIN for the execution of the key to sign the SMS he received, and will send back signed SMS to the provider network. The provider can give the confirm the access to the corporate LAN, and then the user will be granted the access to the network. So in fact, this is a very simple use cases. The interfaces we use here are radius interfaces, so you can exchange the existing authentication platform or authentication token in just some minutes. You just need to configure access to another radius interface and provide that you have a mapping from the user ID to the mobile number. So that's a very easy use case. That's something that's we have a prototype built, and we can now see the performance for execution of this use case. There is much more in the functionality within this mobile ID. Second use case is one that's not based on a secondary device. You can do it without your laptop. Imagine a user that is on a business trip and he has a laptop with him, he wants to access it, but unfortunately he has forgotten his password, did some trials, and the password, his account has been locked. So what can he do? He's abroad, he has not access to his administrator, but fortunately the company has an automated password reset system where he can call with his cell phone, and this APRS, how we call it, is configured to request confirmation through the mobile ID. So what he does is he calls the automated answering system. Again, the system verifies the user if it's in his user database, triggers on the mobile ID backend that the SMS is sent to the user, where the user confirms, yes, I triggered password reset with the system. So the connection is made that what he triggered here, he will receive here as a message. It is not somebody else who triggered it, or it cannot be spoofed from the name because he called here from another phone, or the phone number is verified here, he receives the message. After the confirmation is sent to the mobile ID backend, the mobile ID backend can forward this confirmation to the automated system. The system receives an SMS that is signed with the user key that he has on his mobile phone, so he can automatically verify that the confirmation is from the user, and he can verify CRL and everything that's done within the PKI environment to see that the user is still valid. The important point is he does not need to trust the backend system from the mobile ID. He does not only receive a yes or no, the user wants to reset it, he receives the message as a signed request, and he can archive it for later proof if he needs it or whatever he wants to do, but he can just verify the user will within one message. And then he can generate a new password, set it on the system, again trigger on the mobile ID backend that the new password is forwarded to the user, and because it's encrypted, the user receives an encrypted password that cannot be intercepted on the line and is decrypted on the mobile system where he sees, and then he can enter it on his laptop. That's another use case where mobile ID can be used. We have more of them. For example, if you imagine a signing service is something where you sign legally binding documents. So you need some special key to do that. These keys you normally do not store on the smartphone because they need special protection. You don't want to carry them with you. You can have them in a back-end stored in a HSM module, but you can trigger the signature of a document as following. For example, you have a PDF document you want to sign. You can upload this document to, again, your corporate network where a signing service is running. The service verifies the document. He calculates the hash because you sign a hash of a document. He displays this hash on the user's phone, and at the same time he sends confirmation request, or he requests confirmation through the mobile ID backend, which again sends it a message to the phone. The phone will display the message, you triggered signing of a document. The document hash is as following. Please enter your PIN if you want to sign it. So you can again verify the hash if it's the same hash of the document that you entered there, to make sure that it has not been changed on the way to the signing service. And if you are if you have positively identified the document, then you will again send the confirmation to the backend, and the document can be, the signed SMS will be sent to the signing service, which can verify it and sign the document. And of course, the trigger of the signing can again be archived for later proof that it was the will of the user to use this key. And yes, after the document has been signed, the user can download the signed document. So he can do a very critical operation just by using the mobile phone, or trigger critical operations with use of the mobile ID framework. The last use case I want to show you here is one where the user again has only his mobile phone. Imagine CTO sitting somewhere in a departure lounge in an airport, in another country, is not in the same network as the mobile provider, for example, so you don't know how many roaming instances the messages or the phone call triggers, who is listening to it and everything. When he's there, he's informed about suspected hacker intrusion in his laboratories, and then he decides, okay, we will call our network provider, please detach our network from the internet. Now he calls the help desk, and the poor help desk user there is not really sure, is this really the CTO who is calling, or is that call maybe itself a denial of service attack from somebody else? What can he do? Well, using the mobile ID framework, he can trigger a message, again a confirmation that's asked on, that's shown on the cell phone of the CTO. Please confirm you want to detach the network. If the CTO sees this message and it was him that called there and not somebody else who did this denial of service attack, he will enter his PIN code, and again the confirmation is forwarded to the system where the operator sees that it's the CTO confirmed to detach. Do you have any questions regarding these use cases? Or yes, please.
So when I have his mobile, I can detach his firm from the internet.
Yes, you need, it's a two-factor authentication. You need the mobile, you need to own it, and you need to know the PIN, because that depends. So in our test it's 6 digits, you can set it longer. It's can define it by PIN rule. So it's like a two-factor authentication. You need the mobile phone and you need to know the PIN where to enter, and you are asked each time you want to confirm a message to enter this PIN. So yes.
Then there is one, in my assumption, that there is one major problem with that code, because isn't that your device at any point in time is either connected over an unsecure network, which might happen in exactly the use case where you have the traveler abroad.
Yes.
You never know
Yes.
in Iran, for example, that you have encryption of the wire of the SAN network that you completely switched on, or the other factor would be the CTO installs some application that either is malicious itself or has a bug that's exploitable or else. Then basically having access to that device, not even owning it, you can still basically have a software that does the authentication for you.
So yes, you're right. The question is, yes, the question is about OTP. If you compare it to RSA, you have OTP keys which are generated over time, so they change. And the problem you mentioned here is that if somebody has the key or has installed some software that reads the key, he can execute these actions. So again, I come back to the problem of software on the phone that reads the key. Just one remark regarding OTP. The OTP changes, for example, to prevent replay attacks or such things. And here it's important that if you send this confirmation, that you also have a timestamp here. So I, as CTO, with the name, confirm detach of the network on Wednesday, blah, blah, blah. So the exact timestamp. That's also important if you want to have to archive it for the non-replication and to prevent replay attacks. Yes. That's the second point. So the one point is about changing the OTP numbers so that you don't have the non-repudiation. And the second one is the access to the phone, where I'll come back in a few minutes. Any other questions regarding the use cases? Okay, so I propose that I'll show just a short movie. It has been done by the Swisscom innovation departments, where they think about how the future will look like. They came up with a lot of other use cases I didn't mention here. One is, for example, if you want to monitor heartbeat of people and send the information to some medical center. Of course, it has also to be authenticated and made sure that it's from the right source. But some use cases that are far more in the futures are displayed in this movie. I don't want to go into detail of them, but I think it's an interesting movie. I just wanted to show. Okay. The focus of this movie is 10 years from now, but I think, or I hope that you all agree with me that mobile devices, authentication and confidential transmission of information will be crucial. And now I would like to go into the security considerations for what's the framework to build this solution on. I have here a picture of the components that will be used for such a mobile ID framework. The light blue display the provider infrastructure, and this dark gray are the application providers. So that's basically light blue is the framework, and dark gray is what can be built on top of the framework. So of course we have on one side the smartphones, the cell phones. The cell phones use a specific SIM, so it's a new SIM that provides crypto functionality with a specialized SIM applet that does the functionality of the mobile ID. Information is transmitted to the mobile ID backend, as displayed here, over the air and fixed line access. And the application provider is connected to the mobile phone and to the mobile ID backend through some internet connections. And of course, what also is important, there is a lot of suppliers, there are SIM suppliers, cell phone supplier, other suppliers that are also part of the whole solution. And if we look at the vulnerabilities or at the problems of the solution, we have a lot of them. So the smartphones can be corrupted, the PIN can be intercepted, that's what we heard before. The SIM card can be exchanged, can be another SIM card. The SIM applet can be wrong, can be replaced. Communication can be broken, can be kind of man of the middle, can be changed. We don't have the problems with the backend, so the security of the whole system is quite difficult or quite challenging to prove. What I now want to do is to go through these steps and show you how we will assure that it can be done the right way. What's the most important point is the SIM card. The SIM card is key because it holds the keys, it generates the keys, and it makes sure that the keys can only be accessed if the right PIN is entered. If you want to vote which one of these two is the crypto SIM, is it A or B? So the point I want to make here, it's difficult to tell. You don't see on the SIM card which is the right one. If you want to use a SIM card, you have to start with the right process. You have to retrieve it from the right source. Make sure that on the whole transport it is not exchanged, and all people handling it are confidential or trusted people, so that you have the right SIM card in your phone when you want to use it. So you need a certified track with appropriate production initialization and distribution of the SIM card. As I told you, for this mobile ID functionality, we have seen in the use case before, there are specialized functions. So this one have to be built and loaded on the SIM card. That's a SIM applet. It has also to be stored on the SIM card in a secure way. And today, the SIM card mostly are Java cards, must be built in a secure way. And I have here a picture of what this means. So the smart cards have an operating system. The operating system has to support the security features of the smart cards. Mostly this is proven by certifications. It's common criteria, EAL 4+ or advanced. Then you have a platform, Java platform or global platform on the smart card. Again, this has to be proven that it is implemented in the right way and uses the security functions that are exposed by the operating system. Again, this can be proven by certifications. And what's common certification here is the Java card protection profile that has been defined by the global platform and is also used or basis on common criteria to show it. What this Java card protection profile defines is that the Java card runtime environment, the virtual machine, the APIs are working correctly, that the application themselves are firewalls so that they cannot read data one from the other. The access control to the keys or to the applications is defined. The key generation process and the access to the key generation process is verified that it's done in the right way. And there are there are different sections of this Java card protection profile. So these functions are in the core profile. There's also the smart card platform where the base functionalities are proven. Is it the operating system, the firmware of the smart card? Is it implemented the right way? The bytecode verification, the card manager, the loader. So is the application and the operating system loaded the right way? There are a lot of tests that need to be done to make sure that the SIM card is secure and is able and not been tampered with before you even start using it. And to make sure that you have the right SIM card, you need to trust the provider. And the provider, they can tell you or ask him, are you supporting this Java card protection profile with at least all these groups here? And the best is if the provider can show a test or a certification that has been done by a third-party company that you trust that certifies that it has been done the right way. That's just regarding the SIM card and the applet that's put on the SIM card. But there is a lot more in it, and I think that's one point we made before is the interception of the PIN entry. Today, the communication between the SIM, the crypto card, and the terminal is done in plain text. So everything that goes out from the SIM and is displayed to you, or what you entered and goes down again to the SIM, can be intercepted. I think that's the point you made before. Today, there is no known exploit of that. So that was what was told by Gemalto when we asked them. But in theory, it's possible to do it. And what's the solution is you need here smartphones that are built on the trusted platform where all components themselves are proven and verify that each layer they call are not modified in the meantime. So that's a challenging requirement. The specifications for this exist since some year, but there are no broadly distributed phones where this is implemented. And of course, then, if you have the trusted environment, you have to use the right protocol that makes sure that what you enter on the phone or what is displayed on the terminal is what the SIM sent to you. Today, maybe a word, how is it done today? There is a SIM toolkit, is a specification that's implemented on all phones that SIM cards can use to tell the phone, please display these matches or please ask the user to enter a PIN. And the SIM toolkit is implemented by each operating system provider. And that's the component that has to be hacked if you want to change or to modify or to intercept the communication with the user from the SIM card. But if you have a hardware that's built on that, then you can make sure that the entry cannot be modified and the user sees what the SIM card wants you, what's displayed by the user, by the SIM card. Yes, please. So I agree with you, that's a problem, and I don't think that the current operating systems can solve this problem in short time. So. That's right. So you have to make sure that you have. Yeah.
But we can't verify them because it was like a last-minute commit
Yeah.
and stuff like that.
Yeah.
So it's basically one of the major problems.
Yeah.
Even with all the monitoring software that you have.
I think completely agree. That's a problem that's not solved. We hope that will be solved in future. The specifications exist there, and we need somebody to implement. So the question is, who would implement that, and will users accept such a phone? But because it will be with reduced functionality or usability, whatever it is. So this problem here is right. Is like a card reader when you compare it with regular smart cards. You can use a class 1 card reader, class 2 or class 3 card reader, but it's the decision of the user what he wants to use. And if you have secure mobile phones, they will have reduced functionality. Yes, that's the problem. But it's the decision on the user. We can just provide the platform, and what phone they use is the decision of them. But again, I'll come back to that. Another point we need to look at is the communication from the back end to the SIM card. And a secure mobile ID implementation needs crypto keys that are individual for each SIM card, where he can have an encrypted communication from the back end into the SIM applet that's on the card. So the complete communication infrastructure cannot intercept or cannot modify the message. It's an end-to-end encryption. You have a copy of the key in the backend and a copy of the key in the the backend is here, a copy of the key in the backend, a copy in the SIM card. They are per SIM card in separate encryption keys. It could even be possible that application providers have separate keys for their applications. So each application provider can encrypt from his application to the SIM card. SIM cards have enough storage space for putting enough keys there to support more applications. And of course, again, you need a trusted distribution process where the keys that are put on the mobile ID SIM card are distributed in a secure way to the mobile ID backend and also stored in a secure way. Then there are these usual problems if you look at how uh, service providers, security providers in the outsourcing cloud solutions. You don't know what's really behind it. Is it a secure environment like this one, or is it just some hack? Do they provide their solutions from a secure operations center, or are just providing it somewhere from another country? So here again, the measures would be check for certifications. Examples are SAS 70s. There are other certifications. SOC is one, PCI DSS, and what's important in the area of these mobile ID solutions would be PKI certification, like these ETSI certifications, because PKI certifications look at the whole process also of the user identification, the key generation of the CA key, the complete life cycle of all the keys for the certificates that are provided for the users. But again, here you need to rely on certifications and make sure that the providers use these certifications. A good hint also for what CAs to use or to rely on is look at them if they are in some root certificates programs, for example, Windows, Apple, or Mozilla, because they put severe rules on and checks on what certificates do they put in the root stores, and they also frequently challenge if they are still secure. For example, Windows asked that they will not accept any certificates issued from next year that are using SHA-1, which is too weak, and they are the ones that can enforce it because they see on the clients if a certificate that's been issued after the 1st January 2012 still uses SHA-1, can put it out of the root program. So nobody will do it that wants to remain within this program. That's also a good hint. And certifications, and also look if a company stands with its name in the root certificate. So we all know that DigiNotar, for example. Why did Vasco put DigiNotar in the certificate and not Vasco? If they were sure that it was secure, they could have put Vasco in there, but so nobody knows it was Vasco. Well, we know, but the most of the users didn't know it. Okay, so I come to the end. I think if you look at the vulnerabilities again, there is a risk in the devices. And that risk will remain because today no secure devices are available. There will be available maybe soon, but if users accept it is the other questions. SIM applets, security, secure distribution can all be proven by these PKI standards. Also the communication is encrypted. The processes are covered by the PKI standards. And another vulnerability remains in how is the application provider implementing his solution on the framework and how is he implementing his processes. And regarding the discussion we had before about the devices, so solutions that are defined for mobility always are have some trade-off between the mobility, usability, convenience, flexibility, and user will probably not do any compromise in the mobility or in the convenience, even if those smartphones or cell phones would be available. But think about one problem here. The weakest point now on the solution is not the cell phone, it's the user. And there could be an attack where you say the power plug today use the same interfaces as data exchanges use. There can be a hack or a Trojan in the power plug and read out data, and then you're also done. So it's really, if you want to build a secure system, you have to cover much more than just build a secure platform in here. You also have to change the behavior of the user and what the user accepts and how he handles his phone. Okay, so I think we are through. If you have any other questions, we'll be happy to answer them on the booth we have here. And again, I can also show you the prototype, seeing the performance, how it's doing in the daily use. Okay, thank you for the attention.